Hi, welcome to my tutorial series for the design and analysis of algorithms. In this video, I am going to explain how Dijkstra's algorithm works step by step. You may visit the websites like Geeks for Geeks to get its implementation in Java, C++, Python, etc. So let's begin with an example. A picture on the left-hand side of the screen shows a directed graph of 5 vertices from V1 to V5. The objective of Dijkstra's algorithm is to find the shortest distance from V1 to each of the other vertex. And this graph can be represented in the adjacency matrix as well, where the infinity indicates there is no direct path exists between two vertex. So for example, V2 to V3 is infinity, and you can see V2 to V3 there is no direct path. And to solve this problem, we have to make an empty 2 by 2 matrix similar to adjacency matrix as shown in the right hand side of the screen. Since we are starting from V1, so we write down V1 first. If you are planning to find the distance from V2, so you may put V2 here instead. So let's start from V1. V1 to V1 distance is 0. But we will put a dash here just to indicate that a solution, or you can say a partial solution, has been obtained. V1 to V2 distance is 7. V1 to V3 distance is 4. V1 to V4. V1 to V4 distance is 6. And V1 to V5 is 1. We have to add one more thing in here just to indicate that how we have calculated this distance and from which particular vertex we have got this distance from. So these distances are taken from V1. So 7 is taken from V1, again 4 has been taken from V1 and all other vertices. After writing these values, we can see this last one, which is V5, gives us the shortest distance, which we are going to highlight it as our next candidate. Because this indicates that to reach V5, the shortest distance is coming from V1, as it is also clear from this graph as well. So now let's pick our next vertex, which is going to be V5, because that is giving us the shortest distance so far. And next, V5 to V1 is dash, and V5 to V5 is also dash, because these are known solutions. Next is going to be V5 to V2. V5 to V2 is infinity. That means there is no direct path. But our objective is not to get the distance from V5, but to get the distance from V1. So V1 to V5 is already known as 1. So we have to add 1 plus infinity. So that is going to be distance from V1 to V5 and then V5 to V2, which is 1 plus infinity, which is same as infinity. So infinity is no better than 7, so we will ignore this solution and keep our previous solution, which is 7. Next, V5 to V3. V5 to V3 again is infinity. So infinity plus 1 gives us infinity. So we ignore that solution and keep our previous solution. V5 to V4. V5 to V4 is 1. But again, we are not interested only from V5 to V1, but total distance from V1. So we have to add our previous partial solution. So 1 plus 1 gives us 2. Is better than 6, so we'll pick this solution. After going through all these values, we can see 2 is the minimum value. So we pick this as a winner for now. So that is going to be our next pick. That is V4. So V4 to V1 is known. Let's put these dashes here as well. So it indicates that we have found the solution for these vertices. V4 to V2, where is V4? V4 to V2 is giving us 3. But again, we are not only interested from V4 to V4 to V2, but how did we get up to V4? And we know that is V4 from V1 to V4 gives us 2. So we have to add 2. This solution gives us 5, which is of course better than 7. So our next solution is going to be 5, V4. V4 to V3. V4 to V3, there is no direct solution, which is infinity. Infinity plus 2, you can write something like this. Infinity plus 2, which is also infinity. So we will ignore this solution and keep for V1. Okay. Similarly, as we did earlier, we have to pick the shortest one and make our partial solution. So next solution is going to be, no, I'm sorry, not solution. Next node or vertex is going to be V3. So we keep all these dashes in here. This one is also known. So V3 to V2. V3 to V2 is 2. But to reach V3, the total distance is 4. So we have to add 2 plus 4. But as you can see, 2 plus 4 is 6, which is more than 5. So we will ignore this solution and keep 5 as it is. So that's it. So we have achieved our solution. But you must be asking, how are we going to get the distance from this solution or this matrix? So let's say we want to know the shortest distance from V1 to V2. V1 to V2, looking at this graph is difficult, so we have to rely on the solution. So V1 to V2 says is coming from V4. So if I can write in here, to go to V2, we have to come through V4. Okay, so now we have to come through V4, but how can we get to V4? To get to V4, we have to go through V5. Okay, and how can we get V5? It is through V1. So as you can see from the solution, to reach V2, we have to start from V1 to V5 to V4 and then to V2. Let's see what solution do we get. So V1 to V5 is 1, V5 to V4 is 1, and V4 to V2 is 3. So 3, 4, 5. So total distance is 5. As you can see it here as well. So total distance is 5. So that's all about finding shortest distance for Dijkstra's algorithm. Thanks for watching this video. If you have liked it, please click like button and subscribe this channel to get similar videos. Thank you very much.